You see, I'm basically accidentally cut my screen, not because of me, but because of power cut. Okay, this is what it is, and the other things I need to add here. What is the chat? Just wait a minute. It's I need to find a way to basically optimize these setups like a light fan. Okay, I basically accidentally turn off my mic, and without realizing that, I was speaking for about to 8 minutes. Okay, that's a stupid thing to do, and I did that. Okay, anyway, so this is how the Rusty Crad is basically built, and everything here is basically sort of like you see this these are files, okay? CPU backends, GPU, CUDA backend, ROCm backend, CPU storage, CUDA storage, and so basically I'm separating ops and creation of tensors, okay? Ops is basically the operations you will perform on tensor, and creation is basically you creation how you create a tensor, okay? Tensor is the actual core storage, core structure storage, okay? Core storage of this entire library, okay? If you are doing anything with if you are doing anything with this library, you need to create a tensor, okay? Every operation is performed on the tensor structure, okay? So that's it. So that's how I created. Basically, I separate the storage and the backend thing. Storage is basically for where the actual data lives, whether it's in a CPU, whether it's in a CUDA stack, whether it's in a ROCm stack, something like that. And backend is basically for every operation, which is basically what are the operation you can do to the tensor, what are the operation you can basically uh, use for the tensor, depending on which where it lives, right? If your tensor lives in a GPU, like a GPU memory, GPU RAM or something like that. Like, let's say CUDA, like NVIDIA GPU. If you have NVIDIA GPU and then you basically create a tensor and move the tensor to the GPU, then every operation should be related to this CUDA backend file. Okay, everything is basically defined for the CUDA is lives in the CUDA backend. So what I mean by that is you have a specific matrix multiplication, addition, and every set of things, every operation. Like you cannot basically create a single set of operation and execute both on CPU and GPU. You cannot do that, right? CPU and GPU is a completely different thing. What I mean by that is completely different thing. In the end, they are doing they are built up of transistors and you know registers, memory, and stuffs like that. Everything is same, but their usage and the ability to do things is completely different. Okay, but still they have same set of operations. Not exactly. Could CPUs are very much more powerful and much more smart, I would say, because they can they can basically do lot of variety of operations, but GPUs are very simple, like matrix multiplication, addition, stuffs like that. Very simple operations, but they are very powerful because they can able to do this all the operation in a parallel and processing huge amount of data. That's why they are very powerful. And so the operation stuffs you're the when you are defining operations, it's not basically same for all. You need to create a specific set of operations for everything, right? If you are implementing matrix multiplication CPU, it's not going to work on CUDA. Okay, they have their own API and one set of one set of way to do that. So this is same for ROCm as well. ROCm is basically a CUDA equivalent backend platform for their AMD GPUs, not excuse me. So this is how I built it. So storage is basically have this creation set of APIs, and the backend is basically have the actual, you know, operation APIs. So that's how I basically. So, and then, this thing, tensor is the actual core data structure, and the tensor handle is basically kind of like where you are. It's like it's wrapper around tensor, because tensor is if you're using CPU, then you have this thing called a multi-threading, right? So basically using multiple cores of your CPU cores, and you're basically sending different set of things to different cores, and operating different set of things, something like that. Okay. You kind of you can say something like a parallelizing CPU, right? So that's what you're doing here. And why this tensor handle is needed is basically tensor is wrapped around smart pointers, because every single thing I'm using smart pointers. That's where you actually get the benefits of Rust. If you're using unsafe Rust, there is no actual usage. There is no there is no gain for using Rust, in a sense. You can use it directly C++ for it. Why you are using unsafe Rust and Rust code? But still, sometimes you need that. But until this point, everything is a smart pointer. No unsafe code in the library, and so the tensor handle is basically a wrapper. So what I mean by this wrapper is basically it's kind of like we don't need that. It's like it's basically for this one purpose. You can see that. It's where is that tensor dot. Okay, this is, so here I have this. Okay, this is the exact purpose why I created, because every single time if I want to access the tensor, I need to basically self dot 0, then do that. So for that, for and a lot of other different stuffs, I can basically create this tensor handle. Basically, it's basically for modular structure. So because I can create the higher level APIs, these things, and these things can interact, could not directly interact with the tensor. Instead, they are all going to interact with the tensor handle, right? So then, tensor handle is the higher level API for everyone. Like whether it's a user, whether it's in a library, everybody is basically interact with the tensor handle. The only person can interact with the direct tensor is basically that tensor handle or something like that. I'm not sure about this design, but basically I'm not sure of the benefit of this design. Maybe in the future I can see that, but still now it's not much of a benefits I would say I'm gaining from this. But I keep this. If maybe I can throw it away in the future, whatever. So this is how the library is basically designed. So why am I saying all of this? Because you can basically able to have a context of how these things are building actually. If I just say like fixing bugs, yeah, you're not going to be able to figure out what this, because even a Python, if you're a Python developer, even a Python code base is messy, right? Can be messy. If you are working on another code base, or like another person code base, like who wrote the code is not written by you, but someone else, it's going to be messy. So in Rust, it's a complete mess. That's That's one of the language features of Rust, I would say. but 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 it's a cool language, and that's why I'm basically giving you the basic context of how these things works. Then you can understand. Okay, what exactly he is doing. You can when you're watching the live, you can basically at least assume that what exactly he's doing. He's building this. Okay, he's fixing this for that. Okay, something like that. Okay, I hope that makes sense. So the problem is VM doesn't have have the creation API. Get ready. We need to get ready that. Okay, the parameter type t may not live long enough, so that t will meet this requirement lifetime bound. Okay. So so what exactly I'm doing this line? This is okay. So to be honest, most of this code in this library are written by Gemini, not by me, because you see, I'm not vibe coding. Vibe coding exactly. I'm not doing that, but it's both kind of like human programmer with AI programmers stuff that kind of like a pair programming, I'd say, where two persons sit in a single project working on them at the same time. It's like that. So I'm basically gating this stuff like that. But some of the code I wrote, but some of the code is written by LLM. Okay, that's it. So we have this storage trade basically for a lot of different storages like a CPU. So here they are saying that the parameter type t may not live long enough, so that type t will meet its requirement life bounds. Okay, so what they are saying is the parameter t may not live long enough. Okay, wow. So maybe tensor, no, not tensor, but trade rs. Yes, src. What is the file? It's a storage. Okay. Maybe we can add this here as well. This is basically saying that okay, what exactly it's meaning. We are creating a trade, and we are basically saying that these are the things the trade going to be kind of like an inheritance, basically saying it's like trade inherit trade. Okay, this trade basically need to satisfy that trade. Okay, so that's what you are doing, and this empty and what exact problem is the exact. You see, the static is basically meaning that this should live as long as the main program exists. That's what is the meaning for it. Basically, you're saying that okay, if okay, if some type in Rust basically inherit this trade, then that should live as long as the main function live. That's saying here, and there's a rule for it. Like a custom trade with the custom type with the standard trade. Okay, custom trade with the custom type with the standard trade with the custom type, and that is one thing you cannot do is custom standard trade with the standard type. You cannot do that. And this, okay, let's just, okay, we don't so we are saying this because you see why we are doing this. Okay, let's src slash tensor.rs. Okay, so everything is going to be t. Okay, and the storage is basically storage.rs is basically having this okay, why we are doing this, because storage is basically live as long as the main function exists. That's the meaning of it. So whenever the type that's basically inherit this trade, then that should live for the entire program. So here what we are defining here is basically okay. So here what we are basically doing is we are implementing storage trade for CPU storage, and we are using this T trade. Okay, so it's a two different thing. Okay, the tensor float is a trade, and T is something. Okay, so actually we don't need this, but yeah, we need this because you see, okay, now I can understand why what exactly happening here. It's basically saying that okay, you are implementing TensorFloat, which is a trade for the type T, and the type T need to be basically inherit these traits as well, like float, debug, sample uniform, and sum and static. Okay, because the trade TensorFloat is already inheriting these traits. Okay, so here's the same thing. So we are defining tensor storage for CPU storage, but actually we are at the same time we are using the T trade as well. So T is basically kind of like a generic thing. It's a generic stuff T can be anything. Like it's a F32. It can be anything literally. Okay, but now what we are doing is T is now trade. Okay, so what that mean basically, so tree is a TensorFlow tree. Okay, so what that mean basically, the TensorFlow trade. Okay, TensorFlow trade is basically we are not implementing TensorFlow for CPU storage. Instead, we are taking something, okay, some parameter or anything that's going to use this T. That parameter needs to implement T. Do you understand what I mean? So here there is two different things. Okay. Storage, here you can see that the storage is actually inherited by CPU storage. Okay. But the T is not. T is inherited by someone who is going to be used instead of instead of the methods for CPU storage. I hope that makes sense. Okay. So here you can see that. So we are defining the struct called CPU storage, and that basically using T trade. So T here is I shouldn't say T trade. It's a TensorFlow trade. Okay. So T is a generic type. So this whatever coming here, whether it's F32 or F60, 64, that should need to satisfy this trade and this trade as well. Okay. That's just basically saying that, another way of saying that, let's say if we are doing this here, you can see that. Okay, before I get into that, let's fix this. Okay, yeah, so I think you have some rough idea about how this works. Okay, and then okay, let's fix another bug. We are not fixing that bug yet, but right now we are basically fixing something, but it's not exactly fixing everything. But it seems like TensorFlow is should be static, but in order to be static, we are here you need to understand there is a rule for it, right? You cannot define define a standard trade on a standard type. Okay, F32 is a standard type, and static is a standard trade. So I'm not sure we can define that. If it have the, I think that's the rule. I'm not sure. But anyways, so right now, okay, I need to make sure the F32 have the capability, like a capability of having the static trade in them. For example, string literals. Okay, these are string literals, right? So this is already inheriting this static trade, because they live as long as you cannot change them, because they only live in the static memory. It's only read only memory. It's like, okay, once you define them, they live as long as the main program. The entire program ends, it will live. Okay, so that's it, and let's see another bug. Okay. So what is this error? So they are saying that the problem with the NeoVim right now is basically this. I couldn't see the basically I couldn't wrap the lines, wrap the diagnostics, because you see it exceeds my screen. I couldn't see that, but I don't like that. I need to find a way to do that, because it's somewhere in somewhere I need to configure in diagnostic, Vim diagnostic or something like that. Okay. Okay. So here you can no variant or no variant associated item named matching from the tensor, of course. um okay, let's copy this. Okay, so Barrett, it's I think it's in oh my god, it's storage. expecting expecting function found, expecting function found tensor expecting function. Expecting function. What do you mean by expecting function found tensor? Okay, why it's, what is this ER thing? Is it coming from, okay, I think these things, okay, let's just leave these things and focus on major bugs. Okay, so major issues. And that's it. What we have here is basically, okay, basically, so this is the CPU storage, and we are defining here, and we need to define something fn new, and it's going to take it's going to like a huge amount of stuff. I'm going to return tensor. So not exactly tensor, but instead it's going to return tensor handle. Say still it is a wrapper. Does we have this tensor handle? Use grad. It's grad. No, it's tensor. Okay. Okay, it's not going to. Okay, it's I understand. It's it's not going to create an entire tensor. Instead, it's going to specific data, and that's going to return. Okay, vecti. So that's what it's exactly going to return. Okay, not this one. Can take it out. Okay, it's going to return this. So what it's going to take is basically the size, and size is going to be, let's say, u size, and the t is can I use here t? We cannot do that, right? Then how can I use the tensor float instead of this? Okay, maybe I can use it here. Yeah, that's tensor float. So this is going to take that, and this is going to. Okay. We are basically. I just basically forgot that we are just defining the signature here, not a function, right? So that's it, and we can define something here. F and dot new, and it's going to take a size, and it's a u size, and things like that, and it's going to basically then and that's it, and it's going to basically vector this one and say, and it should be type t, and what is the API for? Oh, sorry, it should be type t, and the type t is basically, how can we define a type t? Yeah, I just sorry for that. I just basically forgot. So okay, So I think it's let's ask, where is that terminal? Okay, how can I create a vector with the f. I basically can use the so okay, maybe we can do that. Maybe we can do the same thing. Is equal to basically back of type t, and we are going to return this back of something usize, and there is whole lot of other things I need to take care, but for now this is fine. And what are you saying? Okay, expecting sorry for that. V. Okay, and what is the size? It's basically u size. Okay, this is okay. That is another set of thing we need to do. I didn't touch that yet. That's a initializer part. Okay, let's just okay. There is a function. I think I have a function. I have a file, which is right now it's just a uniform installation, right? So we need to call that function through that. Says that storage. Sorry for that. Story. And okay. So here you need to basically use grad what is that? Initializer. Initializer.rs. Sorry. Initializer.rs. Here we need to import the functions. Basically, can we do something like this? Um, okay. Unused imports. That's it. And what we're having here is basically uniform initialization, which is a normal way to initialize normal. It's the right way to initialize tensors like array set of things which are basically related to AI, deep learning training, stuff basically related to stuffs like that, machine learning. So that's sad, and it's going to take a data which is a type T, and it's going to return a type T. That's interesting. and where you are using the exact key here. You are initializing the random number, and you are calling uniform new, low, and the high. And for value in the data, that what is data? Data mute. Okay, you are not creating. You are taking the tensor which are already created by. Okay, that's the problem I'm struggling with. No, redefine called storage.rs and see have a okay, I have a API called new. How can I define the vector type t? Sometimes I'm struggle with these kind of simple stuffs because I'm sometimes oftentimes I'm not focusing on the language features like specific nuances, stuff like that, how to create a specific tensor with this type and this type with the capacity. So that's the API for it. Okay. So what is it? It's a storage dot. So it's like okay. Okay, yes, and new functions and storage, and this will create a new vector with a specified type. Okay, so that's how you now we can send this to this. Load the file. Yeah, load the file. So mistyped expecting t. That's it. So actually, so we are going to send this to let's put it in a V right now, and we are going to uniform. It's a T. Do we need to specify this? I'm not sure, but so V and low and the high is basically right now. Maybe we can just set it to something like this. Okay. Low and the high is basically, you need to basically generate a random number between that range. It's a low range and the high range. The exact range, the bottom and the top, something like that. And that's said. Okay, we okay. So it's going to take. I already have associative function new has a 0 type parameter. Yeah, it's maybe we don't need this as well. But how? What is the size of it? Okay, how? Okay, what is the exact API for it? With the capacity, okay, what it's saying is the macro is a single argument instead of square brackets creates a vector with a single element, no vector of create and size. So the create vector just containing the value size. Okay, to create a vector with a specific capability, you should use, if you want to create a vector of certain size with the default value, you can use similar to zero function. Here is the corrected new function I will use with the capability as a general what you want when you know the size beforehand and will fill it later. I will now apply this change to storage.rs. That's not a correct change. What I really want is create. Okay, already we have a 0 which is here. You can see that we are creating that. Then we are returning that, didn't we? So the self dot data is going to be like that. So we are calling this. Okay, we are calling this. Okay, we need to wrap this. Okay, let's just okay. This is the good idea to do. Yeah, basically checking the type, a device, and wrapping this data, and okay, but that's not what we are going to do here exactly. So set relative numbers. Okay, that's it. Actually, this is not a good idea, but just let's just for now let's just leave it like this because this is not a good idea at all. Then what I'm going to do is call this function uniform and basically sending v to it, and low is basically 0. I just hard coding it right now, basically get this get this thing working. For that I'm just doing all of this, but to be honest, this is not a good idea. Argument of this function are incorrect, so it also should be type t. Okay, why? That's not a good idea. Okay, even though it's maybe we can change this to basically wait a minute, and basically change this to f32 instead. It shouldn't be type t. It doesn't have to be type t because we are just setting the range here, nothing more. It's nothing to do with that actual calculation, actual process of calculation. Instead, it's just just a device of the scope. So so we are setting this data to, that's it. What exactly What is the type of it? It's not a type of tea. Then we need to convert this to type. Okay, let's just ask Gemini. Have this function, okay, function called basically mistake function called uniform in initialize rs. I want to make that function return the data as type t. So what you're doing here, read uniform function, okay, blah blah blah, stuffs like that. For yeah, what you're doing, so we change the signature to something. It's going to take a size, and low. Okay, that's a good idea. You are going, where is the data then? What you are doing actually? Okay, you are basically cut this line and paste this line, right? But this is going to be take three set of parameters, which is size, low, and high. And there is no data here, but you are basically, oh, I can see you're creating that. Yeah. So this is another thing. Whenever you try to change with your code base with the AI, you need to basically read what exactly it's doing. Otherwise, sometimes at least you need to have a git you know you need to have a at least you need to commit your changes. If you don't if you basically done nothing, then sometimes you will get into trouble. Okay, we changed that. So expecting type, expected this type. So mismatch type, expecting type t. How exactly it becomes? I don't understand. You're creating random number generator, okay, and you're initializing the uniform distribution. Then you are basically creating a data with the capacity of size. But for I in range, you're basically iterating over to the size and data push is uniform test. But what exactly this data? Data is a not type D, isn't it? Expecting this type parameter. So it's now create and return. How exactly it returns? Is there any way to that? There is another problem with this Rust development. Maybe I'm not skilled enough to figure out that, but oftentimes I feel like if I have a Jupyter notebook or something like in Rust, it would be game changing for me in terms of a development, because you see here I need to run this code specifically. Okay, I need to run this code specifically, like the API and the code. Okay, I cannot basically. I don't have the way to run that because everything tied to main data, and in order to run that, you need to basically lot of files and stuffs like that. But I don't understand. Okay, expecting which cause mismatched type. That's what I'm expecting. How exactly? Actually, it shouldn't be like that. It shouldn't be created like this. It should be created like this. That's it's a good idea actually. You found what? Mismatched type, expecting type parameter found. Is anybody watching our live? Is anybody actually watching our live? Okay, no problem. Nobody watching our live. So we are all alone. So apply this changes. What exactly you change? Uh, um, okay, what you basically are doing is generating that number, then converting them to t. But that doesn't seems a good idea. Because see, okay, okay. What you're exactly doing is, but okay, so that should mean that random number is already generating a number in higher order, higher floating points. Then based on the user input, it just convert them to F32. So if it is generate number in F32, then converting F44 doesn't help because you generated in F32. Then how can you convert us to F64? But anyway, just see. Still, okay. Now we doesn't have any errors. That's a good news. And yes, not okay. Something. So storage. So this is. So it seems like it's a complete mess. You need to send the size, and this should be fine. And the data is now okay. Let's just shit. Okay. Still, I don't understand. Uh, see. It's going to return a CPU. Okay. We have this API. Okay. New has a zero type parameter, but its trade declaration has one type and found zero type. Not exactly a thing. These errors are really hard for me to understand sometimes. Oftentimes I feel like when I read the code, it's really easy for me to understand what's going on here. But when I read the error, it feel like a mess. If I look at the code, I can understand. Okay. This line did this line did that. Then this should be do this. Okay, something like that. But if I reading like this, okay, what associated function new has a zero type parameter, but its trade declaration has one type parameter and found zero type parameter. What it is exactly meaning? Something like that. I don't understand, but when I look at the code, I can understand it. So this is the problem. Expecting expect Okay. What is mean by type parameters? But it trade declaration. Its trade declaration has one type parameter, but found zero type. What is mean by trade declaration have one type parameter? It should be trade.rs. What exactly I'm defining here? It's both frustrating and beautiful beautiful at the same time. If it is not about, how can I call that? Okay. Private method can call. Not sure how to print this, but I think this is the right way to print. I think, but Let's just see whether and there is a lot of stuff we need to uncommand because otherwise it's all going to give us error. Still it's going to give us error because a lot of the bugs we are basically didn't fix yet. Okay, uh, storage, what this exactly found. So it's basically saying that expecting function and found tensor here. So that's just basically meaning that you are expecting function but you found that. But what exactly this is? Tensor dot, so it's not it's error. Okay, so this is defined here, but they are expecting us a function, but this a function? Tensor device mismatch. I think let's just leave these kind of errors and let's just comment this out. Third, return is return this. This is one of the one of things about sometimes you feel like you fix one thing and every other things will break. Because in Rust it's a very you can encounter this very often because in Rust everything should be should be follow the rules. Yeah, in every programming everything should be follow the rules, but in Rust you need to basically very explicit about what you are doing, what you have to, what you want, what you are going to give, and everything like that. If I this is basically this is the problem with the return type because I'm returning this, but this is not the thing I have to return. Instead I need to return this. This is one of the variant of result type. Okay, now found string self tense error. You see, I don't want this. Wait a minute, what? It's expecting self, but before I'm returning some error. Okay. Okay, what? Okay, this function is what exactly? It's okay to back, or it's going to return a self, but this is not a self even. It's not a self either. Self either, right? Okay, maybe I can just turn off these conditions. That's a good idea. That is the only idea I can do right now. Otherwise, I need to define another trade which implement that and this. It's a complete mess. Unused variable, that's not a problem here. Expecting one type. Okay, let's just run this. No, it's going to have a lot of error. What is the error? Okay, I think I am too dumb to understand this error. Let's just ask AI. Run cargo run and fix the error. We have a single error. Let's see. Promote So function signature. So that is a problem with the function signature. You basically changed this to that. But what is t in the case? T is exactly the tensor float, isn't it? Story. See, t is just a tensor float. Then huh, I don't understand because t2 and the t is basically same. Both of them are okay. Due to previous in storage. Okay, didn't I just? Oh my god, this is easy. This is one of the problem. Before that, I just command this. Didn't I forget to save the file or yeah, LLM changed it? I don't understand. I don't know. Basically, I don't know. The thread main panicked. Why it's panic? I think it's something to do with the initializer. No, it's do with main.rs. Because see, okay, so what are the arguments? Okay. We're sending the size and we are just sending these two things. Maybe we can print this. Okay, this is data from storage RS. And it is basically a tensor. It's what exactly it is. It's basically a vector, right? And yeah, I just basically forgot that it's a compiled language, not interpreted language. So in order to find the bug, I need to use a search. Why exactly? I think it's something to do with some mismatched parameters because that's I basically expecting. Say search initializer. We are just using these three modules, and this is going to return the vector t type t, and type t is basically saved in the exact thing, and and then what is the problem? Hmm? What is the exact problem we are dealing? F2 is basically a float, and F2 is uniform. Wait a minute. Wait, what? Okay, what is this uniform trade? Uniform trade and trust. Sorry for that. It's why I couldn't see the hours here. Hmm. Why F32 does implement that? That's not okay. So then trade. Then so among these things, everything is implemented by F32, right? Okay, that just basically means that everything is fine, but there is some error with this. The main is panicked, which is basically mean that in somewhere in our code we are just not handle the edge case. What are the things? So we need to understand what are the things makes the core panic. If we understand that, maybe we can find that. Maybe not exactly. I don't know. Oh, what are the things that 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 makes core main panic? Panic. Okay, when a program it's a unrecoverable error, or if you call panic anywhere in the mind, unwrap. These are the things: unwrap, expect, none error. If you call on panic value, you see, you know what? Maybe we can just um call this sorry, call this function. What is that? It's a initializer. So maybe we can call this function directly instead of going there and just like that. So let e equal to, thus we need to import and initializer size equal to 10, 0.5. E should be snake case. I don't want that. Instead of E, we have E, and no field data type. Yeah, it's not a data. Do I need to provide like this? Or like this? Wait a minute, what? Okay. Syntax error. like this. This. The syntax things. Really need to. I really need to have some experience with Rust. That for sure. I can understand things. I can understand everything works. How everything works at you know at a higher level, like whether is the why it's acting like this, why it acting like that, and these subtle nuance differences. I'm not really good in Rust. That's for sure. But we will get stronger and deeper pretty fast. Cannot be giant. Then can do like this, right? Actually, it shouldn't be. Okay, yeah, how it should be. Can I do that? Could it be like this? Okay, we will find out. Let ask. Chewy. Oh, you are modifying storage data. Hmm? Okay. For today, I think maybe I will back. Yeah, I need to work on it. Hopefully, within today, maybe I can provide a CPU and CUDA backend for it. Hopefully, but that's a ambitious home goal, I'd say. As you see, there is a lot of bugs, there is a lot of errors, but let's see. And thank you for watching. Mm, I hope you learned something.